This video is about applying the properties of rectangles, rhombuses, and squares. So before we get into those three shapes, let's review the properties of a parallelogram. So remember that a parallelogram has opposite sides that are parallel, opposite sides congruent, opposite angles congruent, consecutive angles supplementary, and diagonals that bisect each other. So the first shape we're going to look at that's a new shape is a rectangle. So a rectangle is a quadrilateral with four right angles. A rectangle is a type of parallelogram because if we have four right angles, then our opposite angles are congruent. Because if they're both 90 degrees, they're going to be congruent to each other. So the properties of rectangles, they still have all the parallelogram properties, and then they add two more properties. They have four right angles at the vertices of our rectangle, and the diagonals, the entire diagonal is now congruent to each other. So the other thing that we can draw into this that's new for a rectangle is that our diagonals are congruent. So when they're bisected and congruent, this is now breaking them into four congruent pieces, which is one of our bonus properties. Also with a bonus property, we have two sets of isosceles triangles that are congruent to each other with help of those diagonal pieces. So we have the triangles in yellow and the triangles that are in blue that represent our two different types of isosceles triangles that are congruent. So let's use these properties for the rectangle to solve the following problems. So in the first one, find all the angles of our rectangle. So remember in a rectangle that every corner is 90 degrees. So if this is 22 degrees, 90 minus 22 will get us the other angle at D, which would be 68 degrees. Now remember that we said diagonals are bisected into four congruent parts, which makes our isosceles triangles. And in isosceles triangles, we have congruent base angles, which means that the triangles that are on the left and right all have base angles that are 68 degrees, and the triangles that are on the top and bottom all have base angles that are going to be 22 degrees. So the last angles that we need to find are the angles in the center of our rectangle. So for the blue triangles with the 22-degree angles, we can subtract 22 and 22 from 180. And when we subtract 22 and 22 from 180, we get 138. Nope, sorry, 136. So these angles are 136 and 136. Now to find the other missing angle, we can do two things. We can just subtract 136 from 180, or we can do 180 minus 68, which gets us 44 degrees. Number 2, solve for x and find AC. So when I solve for x, I know that AE is 3x plus 5, EC is 17, and BE is 6y minus 1. So remember, we're also going to solve for y here. Remember that our diagonals are bisected into four congruent parts, which means that if we have one measure of 17 degrees, all of our diagonals are going to be 17 degrees. So we know that this is 17, 17, and 17. So to solve for x, we're going to set 3x plus 5 equal to 17. We're going to subtract 5 on both sides, and we get 3x equals 12. When we divide, we get x is 4. Then to solve for y, we have 6y minus 1 equals 17. We're going to add 1 to both sides, so 6y equals 18. And then when we divide, we get y is 3. The other part that we need to find is we need to find the length of AC. So remember that one part was 17 and AC is the entire diagonal, so we would have 17 plus 17. So AC would have a length of 34. Number 3, solve for x and y. So remember this is going to use two properties to solve for x and y. First, remember that all of our angles in a rectangle are 90 degrees, so one of our equations is 12x plus 6y equals 90. Remember, it also has the property from a parallelogram that the opposite sides are congruent. So our second equation would be 2x plus 4y equals 24. In order to eliminate one of the variables, I'm going to look at the equation. I can see that I can easily eliminate x by only multiplying one equation. So I'm going to multiply the second equation by -6. So I get 12x plus 6y equals 90. And I get negative 12x minus 24y equals negative 144. So when I add straight down, my x's cancel out, my y's leave me with 18y equals negative 18y equals negative 54. So when I divide by negative 18, I get that y is 3. Once I know y is 3, I need to go back and substitute. So I'm going to pick either equation. This time I'll pick the second one. So 2x plus 4y equals 24. I'm going to put 4 in for y. So I get 2x plus 4 times 3 equals 24. 2x plus 12 equals 24. Subtract 12 from both sides. 2x equals 12, so x is 6. So my ordered pair would be 6, 3. The next shape we're going to look at is a rhombus. So a rhombus is a quadrilateral with 4 congruent sides. So instead of 2 sets of sides being congruent, they're all congruent. So there's one side length that's in common with all of them. So a rhombus is still considered a parallelogram because both sets of opposite sides are congruent. So the properties of a rhombus, they still have all of the parallelogram properties, and then they add in a couple more. So we have 4 congruent sides. We have diagonals that are now perpendicular. Remember, perpendicular means that they make right angles. And the diagonals bisect the opposite angles. So B and D are bisected into 2 congruent parts, which makes all 4 angles congruent. And A and C are bisected into 2 congruent angles, which makes all 4 parts congruent. So our bonus property then is that we have 4 congruent right triangles. So let's use these properties and apply them to a rhombus. So in number 4, find all of the angles. So we know that our opposite angles are bisected, so B and D are bisected, and A and C are bisected. We also know that the diagonals are perpendicular, so we have right angles at the center. So now that I know I have right angles at the center, I also know that D was bisected into 24 and 24, and B shares those same angle measurements. So to find our missing angle measurements, we know that a triangle has 180 degrees, and we can subtract the angles we already know. So 180 minus 90 minus 24 will get us an angle measure of 66. So all angles by A and by C are 66, because if I look at this triangle right here, this is one of my right triangles, and remember we have 4 congruent right triangles, so all of them have to have the same measures. So number 5, we're going to solve for x, y, and z. So they told us that angle BEC, so BEC, where E is our vertex, is z squared plus 3z plus 50. They also told us that BAE, so BAE is 5x plus 6y. DAE is 39 degrees. BC is 4x minus 2y, and CD is 4. So remember, in a rhombus, all of our sides are congruent. Our diagonals are bisecting the angles, and the diagonals are perpendicular. So the easiest thing to solve for is first is z. So when I solve for z, I have z squared plus 3z plus 50 equals 90. I can subtract 90 from both sides, so z squared plus 3z minus 40 equals 0. So I need two numbers that multiply to negative 40 and add to 3. So I have z plus 8 and z minus 5. So when I solve, I get z is negative 8 and z is 5. Then I need to solve for x and y, and I notice that I have two equations with both x and y, so it's going to be a system. So I know that the angles were bisected, so I have 5x plus 6y equals 39. And I know that my sides are congruent, so I have 4x minus 2y equals 4. So to eliminate one of my variables, I'm going to multiply the second equation by 3. So I get 5x plus 6y equals 39, and 12x minus 6y equals 12. So when I eliminate the y's and I add straight down, I get 17x equals 51, which means x is 3. Once we know x is 3, we have to go back and substitute. So I'm going to pick the first equation this time, and I'm going to do 5 times 3 plus 6y equals 39. 5 times 3 is 15, plus 6y equals 39. 6y equals 24. So y is 4. So my ordered pair would be 3, 4. Our last shape that we're going to look at then is a square. So a square is a quadrilateral with 4 congruent sides and 4 right angles. So a square is a type of parallelogram because both sets of opposite sides and angles are congruent. So we have 4 right angles at A, B, C, and D. And a square has all the properties that we have talked about so far. So all the properties of a parallelogram, all the properties of a rectangle, and all the properties of a rhombus. So if I were to draw in my diagonals, those are all going to be bisected. They're going to be perpendicular. And they're bisecting those angles in the corners into 45-degree angles. So let's use the properties of a square for our next couple of problems. So in number 8, find all the angles. So nothing's labeled, but remember that our diagonals are perpendicular, so we get 90-degree angles in the center. Remember that all of the diagonals are bisecting the angles in the corner, and since they're all 90 degrees and are bisected, all of these angles are going to be 45 degrees. Number 9, solve for x and find the perimeter. So remember in a square we have 4 congruent sides, so we're going to set those equal to each other. X squared minus 35 equals negative 2x. We're going to add 2x to the other side so that we can factor. So x squared plus 2x minus 35 equals 0. So when I factor, we get x plus 7 and x minus 5 equals 0. So when I solve, I get x is negative 7 and x is 5. Now, we have to look at, do both of those work? So here, both of them would give us positive answers. The problem comes in to this side. If I put 5 in, I would get a negative side length. So this would not work. So the only x value that we have is negative 7. So I'm going to put negative 7 in, and I get 14 on all 4 sides of my square. So my perimeter is 4 sides that are all 14. So I can add 14 4 times, or I can just multiply by 4. And I get that the perimeter is 56.